In Lesson 11.3, you will calculate the degrees of each sector in a circle graph. You will also analyze some circle graphs. Circle graphs can be used to compare parts of a data set to the whole set. The percents in a circle graph add up to 100%, or one whole. In example 1, it says use the information on the right to calculate the number of degrees each sector of the circle graph would be. Since there are 360 degrees in a circle, we're going to multiply each percent written as a decimal by 360 to find the degrees for each sector. So talking on a cell phone is 73%. So we're going to figure out what 73% of 360 degrees is. So 73% written as a decimal is 0.73, and then we're going to multiply it by 360 because we're trying to find 73% of 360. So 0.73 times 360, that's going to be about, we're just going to go to the nearest degree, 263 degrees. Ringing cell phone, that's 10%. So 10% of 360, we're going to take 10% and write it as a decimal, 0.10 times 360. That's going to give us 10% of 360. 10% of 360 is 36 degrees. Now talking to a seatmate is also 10%. So again, 10% of 360, you write it as a decimal, 0.10 times 360 equals 36 degrees. Saving seats. 4% said that would be annoying to them. So 4% as a decimal is 0.04 times 360. That's going to give us 4% of 360. 4% of 360 is about 14%, 14 degrees. And then eating loudly is 3%. So 3% as a decimal is 0.03 times 360. That's 3% of 360, and that's going to be about 11 degrees. Now, if you were to add these degrees up, it should total 360 degrees. Now, it might be off by a little bit just because we rounded to the nearest degree, so you might be off a degree. Now, if you were to actually make a circle graph, you would start out by choosing one of these sections, and you would measure with a protractor 263 degrees, and of course label it, talking on a cell phone. And then from there you would make another one that's 36, another one that's 36, then 14 and 11 to complete the circle. We aren't going to actually be constructing the circle graphs. We're just going to be asking you to find the degrees that you would make each section if you were to construct one. Example 2 says use the information in the histogram on the right to calculate the number of degrees each sector would be if you were to make a circle graph from the information. So this one is a little bit different in that you have to first figure out some information. In this particular bar of the histogram, for 1 to 5 metals, there were 12 countries that had 1 to 5 metals. But it was 12 countries. We have to figure out how many that was out of. It was 12 countries out of, add these all up. This one was 12. This one is 3. This bar represents 5 countries. This represents 1. This one represents 4. And this one represents 1. And if you add those all together, that gives you a total of 26 countries. So this bar right here represents 12 out of 26 countries fell into that category. This one is 3 out of 26. And this one was 5 out of 26. This one is 1 out of 26. 4 out of 26. And 1 out of 26. Now you could go and change each one of these fractions or ratios to a percent by dividing and moving the decimal 2 over, and then do just like we did in example 1, figure out how many degrees that would be. But since we have this right here as a ratio, I'm going to go ahead and use a proportion to solve these problems. For example, in this category of 1 to 5 metals, it was 12 out of 26. And if I want to figure out how many degrees I'm going to make that, 360 degrees is the total degrees in a circle. So I'm going to put that on the bottom because that's the whole amount. And I don't know how many degrees that is, so that's my variable. Now you would go ahead and solve this proportion like we've done many times this year. You would say n times 26 equals 12 times 360 and solve it for n. When you do that math, it works out to be the nearest degree, it's about 166 degrees. Again, remember you would do this times this equals this times that, and then you would solve it for n. Next one, 6 to 10, that was 3 out of 26. So I'm going to write 3 over 26 equals n degrees out of 360. Go ahead and solve that proportion, and you end up with, to the nearest degree, about 43 degrees. We're rounding to the nearest degree because if we were to actually go and construct this, we wouldn't be able to measure anything smaller than to the nearest degree. The 11 to 15 is 5 out of 26. So 5 over 26 equals n over 360. And then when you solve that proportion, you end up with about 69 degrees. The 16 to 20 is 1 out of 26. So 1 over 26 equals n over 360. And then you go through and you solve that proportion, and you end up with about 14 degrees. (21 to 25 is 4 out of 26. 4 out of 26 countries fell into that category. So 4 over 26 equals n over 360. Once you solve that proportion, you end up with 54 degrees. And our last category was also 1 out of 26, so that's going to be just like this one right here. 1 out of 26 equals n over 360. And you solve that proportion and you get about 14 degrees. Now if you were to go and add all these degrees up, they should total 360 degrees, but since we did do some rounding on a couple of these, it may be off by a degree. The last example is analyzing and interpreting data in a circle graph. It says use the circle graph at the right to describe the makeup of the dollar amount Americans pay for their pets. So in this graph it says how much did you pay for your pet, and there's some different dollar amounts, and then it tells you what percent of the people paid that amount. And if you're analyzing it or describing it, you could say more people got their animal for free compared to any of the other categories. Or you could say most people, about half the people, paid $50 or less. Or you could say about half the people paid more than $50. Those are just a couple examples of things that you could say from this graph.